On that note.
Alright, on that note.
Gosh.
Whoa.
Alright, we're recording. We got internets. Get off the farm bill, please. Alright, so I'm going to go over everything you need to know for subnetting that it has to do with CCNA. So I don't know, I'm assuming based on what John has said, you've only been briefed a small amount on subnetting in your classes, so this will be pretty good. And this will be seriously heavy on the CCNA because this is a type of problem you'll see. You'll have a network diagram. You have a IP address here for this PC, IP address here. You'll have the serial link IP address in the middle, and they'll say why can't PC1 ping PC2, and you'll have to, basically it's an IP address problem, so you'll have to figure out if they're in the right subnet or not. So starting out, the first thing you need to know is how to even begin subnetting whatsoever. And basically, you know your standard IP address. This is the one we all know. Whatever. So you got 4 octets there, and you have to know how to turn those into binary to do anything. And each octet is 8 bits. So that'd be 8 zeros, or depending on what the numbers are. Each 0 represents a number. So in all 4 octets, there are 8 zeros. In every octet, the 0 corresponds to a number. And just like any digital logic, 1 means on, or I'm sorry, 0 means on, 1 means on, 0 means off. Right? Am I getting that confused with Linux right now? 1 means on, 0 means off. So for the 192 portion of this address, it would be 128, 164. That's it. So that's how just this portion turns into binary. Is right there. So the next thing to understand when IP addressing is you have network bits and host bits. So if you take, what is this again? Alright, so that's a whole IP address, 4 octets, 8 bits per octet. So, and then you know about subnet masks, which would be, look something like this. That's your standard subnet mask there. And you have 3 different kinds. You have a Class A, Class B, Class C. If you look on this sheet at the bottom, you'll see the IP address ranges for those classful networks. And where it says N on that sheet, that's the network bits. And where it says H, those are the bits reserved for hosts. So in a Class A address, you'll see there, only the first octet is the network bit. So let's say it's the 127. That means all the octets after that are reserved for network, or I'm sorry, host. So you can have as many hosts that will fit into here, which would be 2 to the power of 8, 8, and 8, so 24. And then you minus 2 because you can't use the network address or the broadcast address when you're assigning IP addresses. So this is the math, how you figure out, it's on the second sheet, it shows you the math for every bit length, but you just take the number of bits and raise it to the, or 2 to the power of the number of bits minus 2. So if you need a Class B address, and then these are the host bits, you take 2 to the power of 8 minus 2, giving you 256. No, that's not right.
254.
Well, it'd be, well, the number of hosts would actually be 65,534. Yeah, that's Class B there. Yeah. So, oh. Well, yeah. That works. Alright. So I take it you're all somewhat familiar with at least these basics, so. And then, the next tricky part is when, you're using, classless subnetting when you want to do something like, oh, that is good. If you want to regulate the size of your IP address range, because technically in security you never want to leave extra IP addresses, so instead of having this address, which would leave 256 hosts. So that has 256 hosts because that's the only host portion, not getting any extras. Well, technically 254. So I always include them all because
Yeah.
It helps with my math in my head. So anyways, if you want to cut that down and make it into smaller block sizes because you have subnet that none of your subnets have more than 30 hosts in them. So then you would break that down into a /27, which would end up being just change your network mask. And then that's going to be 27, 224. So that leaves, let's do it this with the binary way so you can see what's actually happening. So you start off with all zeros binary and then, what's that?
Yeah, correct.
Well, what do you mean? They're all ones, not zeros.
Well, I'm not including these.
Oh.
I was just starting here and showing you the bits to change to get to 224, I guess. So, which would obviously be these two. And 128 plus 64 is 192. Is that it? Cheat sheet. Second sheet shows you how they all convert.
Yeah, you're right.
So, this is the network portion, the host portion. And so then you can just figure out the number of hosts in each subnet by taking 2 to the power of 5 minus 2, which is going to be 30. And you officially have, the way I figure out how many subnets are left over, since you take 32 divided by 256, that's 4. So you know you have 4 subnets based on your new subnetting scheme. Is that right? Checking my math as I go.
Well, it would be 256 divided by 32.
Well, yeah. Yeah. No, okay. So you have 4 subnets, and they're each going to be .0 to
That's actually
31.
That's 8 subnets.
What's that?
That's 8 subnets.
That is 8 subnets, my bad.
Yeah, it took me a second.
See, I had to check my math for me here. Alright. So, 8 subnets is going to start at from 0 to .31, then .32 to .63, and so on 8 times. And so then you have 8 blocks of 30 address space. So that's pretty efficient, huh? So from that point, I guess we will move on to the hairier stuff.
Oh, I got a question.
Oh yeah.
What would be the point in doing that?
The point of doing that is if, say you have, this building here has 30 hosts, let's just pretend here. And then the building next door has, or let's do it by rooms. This room has 30 hosts, the room next door has 30 hosts, and the room next to that has 15 hosts. You don't want to sit here and create a whole bunch of IP addresses that have 256 blocks because you're wasting 230 or 226 IP addresses for this room. So by this, you split it up so you can reuse this IP address 8 times instead of having to just use this only one time for each room, because then all your rooms would be in the same logical network. That's another big point I kind of missed on, is you want to separate things in different networks so that you don't get broadcasts from different rooms, or you want it for security or whatnot. So
it'll help the network speed up.
yeah, it helps network speed up because like I said, the biggest thing that they do it for is security, because if you want this to be an academic network and you want that one to be administrative over there, you put it into separate IP addresses. Because if you were just using this right here, and you gave every computer in here an IP address out of that, and then you gave all the administrative computers an IP address, they could all talk to each other, and there's no logical separation. So you don't want anyone on the academic side to be able to even ping those computers, because that's network auditing. Even at its basic level, you can still figure out what's going on. So one, yeah, you do it to separate things logically. 2, you do it not to waste address space, because you have to. You think you have so many, you can get millions of addresses out of one, but when you start breaking things down into networks, and I mean, addresses get used up pretty quickly. So as we can see with IPv4 right now is almost depleted. So yeah, it's you can break it up into chunks here, and which takes on to the next point, which when I took class, they only did this and then stopped right there, and then 6 months later they picked up and showed me this next part. So obviously everyone knows bit location here. So the next part is variable length subnet masks. So these are standard classful subnet masks here, 255.0, and then the next one, as you can see on your paper, would be 255.0.0, and then 255.0.0.0. But also you can do variable length like I showed here, because the variable length was a /27. So that's a variable length instead of using the standard 24, 16, or 8 right there. So, but you can take that a step further by taking the same address, which I do have on this page. It actually shows you how I'm about to break it down as well. So, taking this address, it started out as a /27 /25, because it had 2 blocks of 120 each. Yeah. So right now, this octet, the way it stands right now, is broken up into 2 large blocks of 128 each. So the first block is 10.0 to 127. The second block is 10.128 to 10.255. But say you do have 128 hosts on this network, so you want to leave this intact, but you still need to, maybe you're adding a couple rooms with 30 hosts on it here or there, and rather than moving to the next whole octet to create a whole nother thousands of hosts and multiple subnets, you can just take one of these chunks and break it down further. So the best way to look at it is to look at this right here as a chunk of 128 addresses, because it is. And what you're going to do is you're going to change the slash notation, because this 27 obviously is just the same as this right here. So you're going to change that, and you can only lower it. You can't get more addresses out of nothing, obviously. So if you're going to take a portion of this and break it down. You're gonna change that /27. Well, I'll do it with the second half actually. I'll do it with this half. So we'll take the 128. We're gonna break it down and do a 25. Or I mean a 27. If I could just keep a straight thought, it wouldn't be so confusing. So then what you do from this point is you're taking this block of 128 addresses and you're going to subnet that block into additional subnets. It's the same thing as taking an entire octet and breaking it up, but now you're just taking a half of that and breaking it up. So at that point, what you're going to do is split up based off of this 128 as if that was just your 0 starting address. So what you end up doing is you're changing to a 224 address like we had here, and that's going to give you 4 subnets out of that half. So you've just quadrupled the amount of subnets you have by just changing your network mask. And then it creates that address range that I have right there. The only thing that gets confusing is, I mean, you can keep doing this all day. Like you have those 4 right there. Well, you could take the .160 chunk of 32 addresses and subnet that into 2 chunks of 16 addresses or 4 chunks of 8 addresses. So that can just keep on going. But the problem is that you'll run into is once you head down a path where you're doing 26 and 25, you become less flexible because your host size is continually shrinking. So it takes a lot more planning to do it this way, but it's way more efficient because if you plan accordingly, you can not have any extra address space and still only use what you need to do while leaving room for scalability, because with IP address spacing, they say should always leave 20% for scalability.
So you would have to plan your network for those extra computers that you would add later on?
Yeah, you just
because
keep
you would
in
have to
mind,
redo it all.
yeah, because you have to redo your entire IP addresses. And like especially with networks like as big as Owens, it would get pretty nasty to re-IP. I mean, especially when you're talking about having static IP addresses on a lot of machines and stuff like that, and you have static IP addresses on all your switches and routers for the most part, and so yeah, it'd get pretty hairy. But I feel like I've skipped a step here. So you know how to get from a regular address, you know how to subnet that based on your network bits and your host bits. You do the same thing when you're doing the subnetting further, except now you're just taking, this just turns into, math on the fly. Oh, that's easy. So now if you're taking a /27 of that, you're officially moving from a 25 to a 27. So you're moving from left to right and you're borrowing these 2 bits for the network officially. Sorry, these 3 bits. Because we were already borrowing this one. Because by saying /25 is saying that you're using all of those for a network, and you're leaving these left over for a host. So, and then once again, you just take 2 to the power of 7 minus 2 to figure out how many hosts that gives you.
So it gives you a smaller range of hosts.
Yeah, it gives you a smaller range of hosts, but it increases. You're basically, yeah, it gives you a smaller range of hosts, but it gives you more logical separation out of that one subnet.
So more departments.
Yeah, more subnets, because I mean you can have, I mean you could have a 1 dot address for your entire network and put every single host on that network and just have NAT working on your border, but you wouldn't be able to logically separate things. There would be security issues. You'd have broadcast storms. Like I saw a sweet YouTube video of a broadcast storm being simulated where basically there's like 20 computers that there's a loop set up in a switch, because you have two Ethernet cables going to the same switches for Dunsey. Well, STP wasn't set up to take out one of those links, so as you broadcast and the switches multiply the broadcast out to all their ports, all of a sudden they're broadcasting a broadcast, and it's pretty hairy. So yeah, so logical separation for security, reduce network traffic in areas you don't want it to be. What other things? Yeah, I mean, that's pretty much the basics there. It's just logically separating things. So, but yeah, it takes away your IPs, but it gives you more containers. That's exactly it. So, I want to make sure to hit on this, okay? Because like, if you look at your sheet and you see like the first one, the first table on the very front, the first row, the column I should say, has a slash. Well, that's your slash notation. So like that /8 is saying that this is the only network and these are all hosts. And the /18, let's say, is going to say that that's 8, 16, 17, 18. So there's 18 network bits, and then the rest is 8. I should be able to do that math in my head, but thank you. It's pathetic, I know. Okay, so normally I'm pretty good at simple math, but anyways, 2-digit math. Anyways, so yeah, that's how you figure out the /dot notation. So that's going to equal a /18 network. If you move this over 1, /17, /14, /15, I should say. So, okay, and now we'll move on to the fourth stage of IP addressing and subnetting, which is summarization, just summarization or supernetting. That's the word I was looking for. And this is a very important part of IP subnetting because routers do this automatically. At certain points, routers recognize that an IP address is subnetted, so in order to not flood every subnet's broadcast out of, let's say this was subnetted 10 times, there's no reason to flood every single one of those subnets out this router and over to this router, and then they're going to have all those IP addresses in their routing table. And all those IP addresses will be in that routing table because the router has to look at that routing table every time a packet comes at it to see where to send it. So if it has to, if this host is sending an IP packet to some host embedded in this subnet, then it's going to have to sit here and go through this like massively large IP table to find it. Whereas when you use summarization, it'll take this entire big subnet, summarize it into one address, and then forward that packet out of its external interface, and then we'll have the one summarized IP address in its routing table and the one summarized IP address here. So that way, if you're sending a packet to this guy, it just says, okay, I know I reached this network out of this interface, send it, and then this router will do the work to figure out, well, for the most part, it's just send it through the switch and it'll find its way there anyway. So yeah, summarization, very important for reducing network traffic and increasing routing efficiency. Alright, so I put an example on the paper under summarization, so let's do that real quick. So it gives you those 4 addresses there. The important thing to look at when you're looking at that address is what parts of that IP address is included in the network portion and what parts of that is part of the host portion. Now it looks like technically that only the last octet is part of the host portion, but actually since we're summarizing, it is going to float in that other octet and you'll see it. But at first I'm just going to draw that as all zeros. It's not totally important. So, damn, I should have done. Oh, I already did it. Sweet. So we got that address. So those are all those addresses converted to binary. You have to do this for summarization for the most part until you become comfortable with the numbers that are associated with IP subnetting. I mean, if you look at the charts, you'll see that recurrent numbers appear all the time, like 128, 192, 224. Those numbers appear all the time. Then obviously the 128, 64, 32, all the way down to 1. Those numbers are going to be there all the time. So eventually, if you get good enough to where you can take this network mask and figure out what its binary representation is in your head by knowing what bits add up to 224, clearly I don't have the capacity for that, so I write it out. So what you do from here is to figure out how to summarize it. The only way it can be summarized is if you take everything that is in common. So sometimes you'll see, like if you look at, actually these are pretty diverse, but sometimes you'll see maybe only these 4 will be in common, so you'll draw a line at those 4. And those are, you're going to turn those into zeros for your summarized portion, and then the rest will actually, you'll count them up, and that'll add up to the address that's summarized. In this case, which I guess is probably not the best example, but since none of them are in common, you summarize from this bit. So it's actually very standard summarization. It's very clean. But if you did it, let's say this, it doesn't matter even what those end up being if you add them all up. So you're drawing your line here because that's what's in common on the left, and on the right it's all different. So if you're doing if you're putting that back into numeric value and trying to figure it out, damn, I screwed myself. No, it wasn't too bad. So this is still the 101, 122. That changed to a 3 and a 5. A 5, and that's a 1 plus 64 and 32 equals 96, 97. Okay, so those are your starting IP addresses now after I changed them. And when you're done, it's just going to be .0 because there's nothing there. Because our original address was .10, whatever. And your slash notation isn't, based on this example, isn't going to be the same as the paper because I changed those first 2 bits. But when you're doing summarization, you're counting the bits from this portion of the network mask, or the IP address over here. So you're actually, your summarization is going to be 8, 16, 24, 25. Whereas in my example it's 24 because since these were different, you actually started it from here. So that's where your summarization of host bits began, and that's where your summarization of networks began. So in my example, you can see it's just a .10.0 as well. But since the, am I doing that? Did you see this? Did I do that right? You didn't see it, did you? I'm not sure. I'm pretty sure I did that right, but it makes a difference. It makes a difference because your slash dot notation, that network mask means a lot. So, I mean, this is the proper summarization. So this is what you'll see in this router. Even if this thing, I mean, 161 is a valid address because it falls within the 190.10.60 to the 190.10.191 range. So that's a valid address. And if you were to subnet that all the way down to, I mean, you would have, since you're subnetting the subnet, let's say you had .90 address, that would be on a different subnet as this, but you would still only see the /25 address. So that's all I have to ramble on about. Does anybody have any questions? Ms. Dix?
What happens if it's like, if they're all the same, like in the middle or in the other end? Does anything change?
Oh, for summarization?
Yeah.
If they're all, yeah, you just move that line over. So, well, let me look at it from this perspective actually, because you want to focus what you're looking at based on your network and host bits still, based on your network mask. So I mean, these, based on this address, I mean, yeah, these bits here are not gonna match these bits or this. But you're summarizing based on your host, so you start from the right when you're summarizing. And you only turn into binary what it is that you plan on summarizing. Since you don't plan on summarizing the 192 and the 168 because they're the same throughout the subnet, you don't have to. But if you had a class C address, or class A address, sorry, that was 127 dot whatever, you would have to, and say these were all different subnets right here, and maybe this was something random and that was something random, and you want to summarize a big list of those addresses, then you would have to start looking from here over. So you would have to turn each one of those octets into 8 binary values to figure that out.
So you can't do more than one octet at once?
Well, yeah, technically this would be summarizing more octet.
Okay.
Because when you finished this summarizing, it would probably look like something, this is imaginary as hell, but let's just say, it would probably look something like this, /9 or something, I mean, who knows. But, so technically, yeah, you're summarizing all the bits up to, I mean, all the bits up to there at that point. So you're still summarizing half of that octet at that point.
I meant like in the post, like if, it doesn't matter if like all of them are like right in the middle, it's like all of them are the same all the way down, like does that mean anything or?
No, it doesn't mean anything. You just want to start from the left, and whichever ones are matching, that's what you're going to use. So let me give you this. Let's see. So 1, 2, 3, 4, 5, 6, 7, 8. These don't line up that good. But if you look, I screwed it up. No, I didn't. Yeah, I did. 0, 1, 1. That's what I need here. 0, 1, 1. 0, 1, 1. 0, 1, 1. That doesn't work either. Yeah, that works, actually. Okay. So since you see on this one, the zeros all match up, the next one all matches up, and the next one all matches up. You only finally get your difference when you cover those up and you realize you have 0.
0, 1, 0, 0.
Yeah, a bunch of zeros and a bunch of ones. So at that point, the only thing that's different is that 1, but that's where you stop. So your line would go like that. And now what you do is you summarize based on these bits, because those are the matching bits. So your summary address would be, I just did this 97. So it'd be 192.168.10.97 / now you're sharing 24, 25, 26, 27 bits. So that would be your shared address.
But what if on the second post you changed the first 1 to a 0? Where would you just stop at the beginning?
Yep, if you change
Even though
that
the
to
next
0,
one-
then that line no longer matches up, and now you use this line.
Okay, even though the next one would match up?
Yeah.
That means nothing?
Yep, you go left to right, and
Gotcha, okay.
So did you just subnetted a subnet,
Mhm.
so that gets rid of even more IPs that were open.
yep,
But can they talk to each other? Can the subnet of the subnet talk to the
with a
subnet?
router, just like any
Okay.
other. If you have a 1010 address over there and I have a 192 address, the only way they're talking is if you have a router that says they can talk, and there's
Through
a
the,
route
yeah,
in there.
through the tables.
Yeah, I mean, I could do. You want me to do another example of a subnet and a subnet? Because that's the most complicated part, to be honest. I mean, this is probably the hardest thing that I had to wrap my head around. When
If you
I
have time, that'd
learned
be
networking.
great.
Yeah, I mean, I'll bust one out real quick.
When you summarize routes, does only that router's is the summarized address, the other one can see all the subnet?
Yeah, this one will see all the subnets. If you look at the routing table of that router, you would see the summarization address, and then you'll see a tab, and then underneath it, it'll show the rest of the subnets as a whole. And so, yeah, any other device past that router, even if there was a third router over this way, I mean, that would still only have the summarized address. Routers do it automatically, so it's not something you have to configure, but something you have to keep in mind when you see questions that'll say, they'll even tell you, I'm not good at it, so I'm not going to show you, but they'll show you a summarized address and tell you what addresses come out of there, which is not super hard, but like I haven't practiced it, and I just made sure to brush up on this stuff today, so I didn't, because I don't want to give you false information at some point, because that would really screw you up. So, but yeah, you can do the same thing with the summarized address. You can look at the bits and make a guess at what kind of the range of IPs that would come out of it, even though I don't know if they're necessarily like 110% accurate. So, all right, so let's switch it up. Take a 10, got 100. These are gonna be crappy numbers. Well, that's okay. Got 224. Got 0 address. And that's a /19. And that subnet mask is gonna look like this.
Was that already subnetted?
Technically, yes, it's already subnet past the classful bounds. Because if it was classful, it would be an 18 address, or a
Okay,
16
yeah.
address, I mean, which would mean, because whenever, if you look at the chart, whenever you see anything other than a 255 or a 0, that means it's beyond classful subnetting. Like, even though this first one says the 192 is a Class B network, technically it's not a fully Class B network because you're using half, or a portion, a fourth of that, what is that? Yeah, like a fourth of that network. And everything is classless now, so you're not going to see that. It's the most inefficient way. It's just a way to like kind of get your feet wet. So, yeah, when I look at this chart, I ignore the Class A, B, and C stuff on the left. And when I'm looking at the number of subnets on this chart, I ignore the Class B and the Class C columns. Because technically, when you're looking at classless subnetting, the columns that are going to be correct are the Class A columns. Because that's as if you were, that's the most accurate representation of classless routing or subnetting, because they're constantly building on each other. Okay, so we have this address that's /19 notation, // whatever. And that's 224. It's really bad. I can't do that quickly in my head. Okay, so there's your subnet mask. And obviously, those bits. Oh God, see? Dyslexic. Those bits. So to subnet this, right now, let's just figure it all out while we're here. This is a full 8 octet we're using for host. Now this one we're not using all 8, the full 8 octets for the host, because we're gonna have use 224, so 3 of those bastards. So when you break it down, there you go. So that's the number of networking hosts out of that network mask. So so you have a full 8 in the first octet, and you're only using 5 for the host out of that octet. So you're going to take 2 to the power of 13 minus 2 to figure out the number of hosts, which is 2,048 at this point, because that is network, sorry. Thanks. So that's 8,190 hosts, total hosts, that are usable. Alright, so say you want to break that down into many more subnets, because you don't have one large network that just uses 8,000 hosts. You have a bunch of different rooms that you need, a couple hundred IP addresses in each one. So we'll break that 19/19 down into a, make it a nice round number, /20. Alright, so we're gonna break that down. And also, before you start subnetting, you need to find an IP address block of actual IPs to break down. So the first block in this address is gonna be .0 to dot.
So you actually use the .0 address?
Or you include it. I include it when I'm because you include it because it's part of it's part of the whole block. Even though you don't use it for putting it as a stack address on any device, it's still part of the address block. You just have to know in practice never to set a computer to .0, and everybody uses .1 for a gateway, but you don't have to. You can use .36 for your gateway if you'd like.
Okay.
So there's 8,190 hosts on that bad boy, and there is 2,048. Not 36. See, I was using easy numbers earlier because I had time to think it out and I wasn't on the spot. So, well, let's just, yeah, I forgot what it says. 224, 5 minutes being used, first 3, so it's going to be an address within that range. $8,190. 2,048 subnets. Can someone do the math on that? If you do, no, that wouldn't work actually. That doesn't work for reverse math. I lied. See, earlier I did just an even /24 network, so that when I took it to a 25, it was easy to see. So I'm gonna do that again because it's easier that way, for me at least. And yeah, I need to study too, clearly. So we'll just make that /16, which is saying that this is a 0. So then your first address block is going to be 0 to 256.
Don't you want that to be a 15 and then go to a 16?
Well, I'm going to do a 16, so I meant even 0, and I'll
Okay.
break that down further into a 17,
Okay.
which makes it easier. So okay. So assuming that we're leaving at 0, there's going to be 255 hosts in there for each one of those that you change to a 1, 2, 3, all the way up to 255, which would thus create 8,190 hosts. So that's your block size you need there. And so we're going to take that down further. We'll make it a /17. And I'm not sure what standard practice is on this, but you probably want to use the last block in the subnet, because then you have your big blocks towards the top, and then you make your smaller ones towards the bottom. But that's just to organize things. So you're going to start with the 0.0 address, because it is still a valid address, and you're going to take it to 17. So by taking out an extra bit for the network, your 0 obviously looks like that, and instead of your network being here, now your network is there. So now you have anywhere from, damn, how am I getting lost right now, man? That's why I made this one beforehand, so that I could see what everything was going on before I had to do it. So anyways, so 0 to 255 is now going to be broken up into blocks of 128. Oh, that's all it's doing. It's just splitting that in half. So now you just subnetted this block into 0 to 128, or 127, and dot 128 to dot 255. So now this chunk alone, by doing that, is now broken into 2 separate logical chunks. So officially, even though if you look at this address without the network mask, it's going to look, you can't make sense of it. The network mask is key. Because technically this address with this network mask is valid with any other IP address in that network, in that subnet. So by adding the 17 on it, you logically separate things, and these now become their own logical networks separate from the original network as well. I know that wasn't the best example, but when we do a CCNA study group after I studied up on it some more, because like I said, this is the hardest thing to grasp. I mean, you can learn the names of routing protocols, you can learn stuff like that, but this is just like a tricky thing to figure out like through and through, because you're just talking about shifting digits around and bits and creating logical numbers, even though technically it fits. Because I know you're going to see questions on the test that's going to say, I'll show a diagram like that, but maybe it'll show something like, says, so you have to know that that's the symbol for a crossover cable, pretty much always, I'm sure. So they're going to say, oh, why isn't this network connecting? Well, you say, okay, well,
It's got holes in it.
that's a there's no data getting through there. So you're going to say that, that's a crossover cable, so that's legit. Those are talking. And you're going to say, the important thing with serials is making sure you have one end that's DCE, and one end that's DTE. And you say, okay, I know that that's okay. I've seen what's going on in the config. Maybe they showed you a little chunk of the config there. And you say, okay, I know those are both straight throughs. That's how that's going to be. And then you're going to want to be like, okay, now I got to look at the subnets to make sure that they are subnetted properly, that they can reach each other, or that they have the proper routing information. So, and like I said, when we do a CCNA study group, I'll go over it more because I'll have more practice. Because like the summarizing stuff, like I just started like grabbing a hold of it a couple weeks ago, because what we were doing was we were going on routers and actually taking off route summarization. So then you can see what it's doing, and it makes it look a lot easier. But it gets tricky when you've already subnetted subnets and then you're summarizing them. Like subnetting subnets is tough too, because you already had a hard enough time figuring out a variable length subnet mask with like a /19, and then to make that into a /20, it's like, okay, so now you gotta do the whole thing over again, but now you're dealing with smaller logical blocks. And the way I divide blocks in my head is easier when I'm doing zeros, because you know that this block is 256. So when you split that up the first time, you're only cutting in half. The second time, you're splitting it into a fourth, and the third time, you're splitting into eighths. Everything doubles on itself. So there's no odd numbers really in networking. So yeah.